yesterday, or I guess not yesterday. Yesterday was the SAT, but Tuesday, the 6.4 lesson went over end behavior for polynomials. So this one is focusing on end behavior for rational. Okay, so this unit 6 that we're in is going to cover polynomial functions and rational functions. We're covering those together. Okay, so this is our first lesson on the rationals, and we're going to look at their end. How do we determine what their end behavior would be if we don't have a graph to look at to just see what the end behavior is? Okay, so we there's like 3 learning targets here that we want to focus on. When I post the completed notes for these CalcMedic lessons, the ones that are all in this format, when you see sometimes it's just a bullet, but sometimes it'll say LT. And if you're wondering, that's learning target. So it's like the main points of the lesson. So this one has 3 that we want to focus in on. So the first one is that rational functions have the form and we're going to call it h of x equals f of x over g of x. So essentially a rational function, which we're calling h, is the quotient of 2 other functions, one function over another function. That's what makes it a rational function. Okay, where f and g are polynomials and can be used to model real-world relationships. Like the anesthesia situation on the back. Would be a real-world relationship that's modeled by a rational function. Okay, so then the second learning target is that comparing the degree of those 2 polynomial functions, the f and the g. Okay, so comparing the degrees is going to indicate whether the numerator or the denominator is the higher degree, which one is dominating. Okay, so comparing degrees of f and g indicates whether numerator or denominator is dominating. All right, and then the third learning target, try and, if you can, squeeze it in, because I want to leave a little space for an example or 2. Okay, is that to determine end behavior you can analyze a simpler function given by the ratio of the leading terms. Of F and G. Okay, so that takes it back to what we talked about in 6.4. The leading term test for polynomials, we're looking at, is it even or odd degree, and is it a positive or negative coefficient, right? So what this is saying is that for a rational function, we can simplify this down just looking at we're just going to focus at the leading terms and simplify it down. And then we'll use what we see, what we're left with, to determine, as we plug x, a very, very large x in, so as x is approaching infinity, okay, what's happening to the function. So we'll use what we talked about in the last section. So let me get an example up here so you can put that into practice. So let's say we have 3x to the 5th plus 2x squared over negative 2x squared. So we've got a polynomial with degree 5 in the numerator and a polynomial with degree 2 in the denominator. Y'all agree? Okay, it's the highest degree that we're looking at when we say what the degree is. It's the highest exponent. Okay, so this, you don't need to be able to picture this exact graph in your head just by looking at it, okay? But we can figure out what the ends of the graph, the very far left and far right, will be doing, because this is going to act like just the 3x over 5 over negative 2x squared would. All of the other terms in either polynomial don't affect the end behavior. Only the highest degree terms, okay, and those leading coefficients matter. So looking at the degrees, what does x to the 5th over x squared reduce to? Just x cubed. And then the 3 over negative 2 just becomes negative 3 over 2. Okay, and so it's just an x cubed in the numerator, right? Do y'all agree with that? So this rational function is going to behave the same at the end as this cubic, this polynomial, which we said in 6.4, if it's an odd degree and a negative coefficient, what would the right side of the graph be doing? It'd be decreasing, it'd be falling. Okay, so it's going to act like this function for large values of x, meaning if I plug in as x approaches infinity. So if I wanted to, I could go ahead and write get a different color here. So I could say the limit as x approaches infinity for this function, we'll say we called it h of x. Okay, so for this one, this end behavior on the right side as x approaches infinity would be the same as this polynomial, which you know based on leading term test is negative infinity. Does that make sense? Yeah. Okay, we're gonna do one more example. Example 1. What will happen if I have 2x to the 4th plus 5x over x to the 4th minus 1? This is going uh-oh. My pin's acting funky. This is what happened at the end of my last class, third period too. Right when I got to the end, my pin stopped working. Oh my gosh. All right, if I look at just the leading terms, what are they? Two x to the 4th for the numerator, right? And what for the denominator? X to the 4th. And because they're both x to the 4th, they're the same degree, what happens? Yeah, it just reduces. So you're left with just what? Just 2, because the x to the 4th over x to the 4th reduces. I would like to be writing this, but my thing stopped working. I'm going to try and write this with the touch screen, just with my finger. It's probably going to be kind of poor handwriting. It's too thick. Let me try zooming in first so it's a little better. Oops, sorry. Okay. So this is going to act like 2x to the 4th over x to the 4th, which you told me would reduce to just 2. So for very large values of x, that's how this graph is going to behave. So if I wanted to write the limit as x approaches infinity for this one, what would it be? What does the graph of 2 look like? Y equals 2. It's horizontal or vertical? If it's y equals 2, it's horizontal. It goes through the y-axis, right? So we have a horizontal line at 2. So what are the ends approaching? 2. So this limit would be 2. What does that tell you about this rational function? What does it have? What's that? What y equals 2? That's an asymptote. If the ends of the graph are approaching that specific value, that means there's an asymptote there. Okay? When you went through that Desmos yesterday or last night, whenever you went through it, maybe it was Tuesday, hopefully you kind of started getting a little refresher, remembering from Algebra 2 about rational functions having vertical and horizontal asymptotes sometimes. Okay, so this end behavior is approaching 2. That means there's a horizontal asymptote at 2. Y equals 2 is what that tells us. Does that make sense? All right, so we can determine the end behavior of polynomials by looking at just the lead terms and comparing those ratios of those leading coefficients. You'll feel okay about that? All right, since my pen stopped working, I'm just gonna pull over to go over the backside with you instead of writing things down and filling it in as we go, since for whatever reason this isn't working. I'm just gonna pull over the completed one that I already have, and we can go through it and you can double check yours and let me know if you have questions and we can talk about them. All right, So the scenario is a patient's undergoing surgery. The anesthesiologist must administer the right amount of drugs to help the patient keep them sedated during the procedure. The well-being of the patient depends on the doctor's ability to predict how long the anesthesia will stay in the patient's bloodstream. How does he or she do this? Okay. The first question says, what do you think would happen if you received too much or too little anesthesia? Your answers will vary. If you got too little, you could wake up during surgery, or it could maybe not knock them out, or they maybe could feel pain from the procedure, whatever's happening. If they got too much, it could take them longer to wake up. Actually, it could kill them. But so that's why it's a very precise science that you have to have the right mathematical equations to get the right amount of anesthesia so that those aren't any issues during the procedure. All right, on number 2, it says the concentration of anesthesia in a person's bloodstream can be modeled by C of t equals 35t over t squared plus 6. So in this rational function, does the numerator or denominator dominate the function? Which one's larger? Degree. This one's the denominator. Okay, in the example we did in the quick notes, the numerator, or the second example we did, they were equal. Okay, they were even, and that's why you ended up having that asymptote, because the degrees were the same. In that top one, that first example that we did, the numerator was a higher degree, so the end behavior went up or down forever. It was not approaching an asymptote because there was no horizontal asymptote, because the numerator dominated the function. Here in this one, it says that I'm just pointing this out. This isn't part of the question, but I just want you to see the difference. The denominator dominates the function. So this is a case where there is going to be an asymptote at the axis, at y equals 0 is what happens if you've forgotten that from algebra 2. So if the degree of the denominator is smaller, you're going to have a horizontal asymptote at 0. If the degree of the numerator is larger, there's no horizontal asymptote. And if they're even, that's when you have an asymptote at a specific number, whatever that ratio is. In our example that we just did, it was 2. Do y'all remember that from algebra 2? Okay. So this one says C is given as a percent and T is in hours, and the graph is given. It says, what do you notice about the graph and what do you wonder? Y'all's answers will vary there. Hopefully you noticed that there's, an initial spike and then it's decreasing over time. Okay. What you wonder may be different. So that there's no right or wrong answer for A. That was your opinion. B asks, what's the concentration of anesthesia after an hour? So it says that time is in hours. So we look at 1 hour, and that looks to be at 5. Okay, and it told us that Y value would have been, yeah, so we can look at it here. It's the concentration of anesthesia after half an hour. So we plug in the 5. Are there 0 point? What does it say this is? Oh, that's 0.5? So that they didn't label the X and Y axis on here. I don't know why they did that as 0.5. Oh, thank you. I was like so confused. I'm like, I'm not reading this graph and what was plugged in correctly. Thank you. Half an hour. I just totally read over half. Okay, so we look at half on our graph and go up, and that's just below the 3. So you could estimate based on the graph that it would be between 2.5 and 3, which if you plug in the time as the 0.5, then you calculate it exactly, it comes out to the 2.8, which shows it correctly for what we estimated based on the graph. Okay, and then the concentration of anesthesia after 24 hours. Okay, so that does not show on the graph, so we can't estimate based on the graph. So you would just plug in the 24 for your T and calculate. So it says about 1.44%. And then after 48 hours, it comes out to about 0.727%. Questions about that one? Okay. On number 3, it says that the anesthesia is considered effective at a concentration at or above 5%. How long should the surgeon wait to start the surgery? And then how many hours is the anesthesia effective? So if you look back here, that's where this dotted line is drawn at 5%. So they should not start the surgery until about an hour after it's administered, when it reaches that 5% mark. Okay. And then on number, oh, it was 2 questions there. How many hours is the anesthesia effective? So it's where it crosses that threshold at about 1 hour until around 6 hours. So that's a total of 5 hours. Everybody good with that answer? They said in the question, it says anesthesia is considered effective at a concentration of about 5%. So that's why, yes, the y-axis that's our C of T, which they said is in percent. Okay, so that's our 5% threshold that we're comparing to. Good. And then it says, after many, many hours, what do you anticipate will happen to the concentration of the anesthesia? And hopefully you said that it will go to 0%. It'll eventually be out of the bloodstream completely. Okay, that's your asymptote, isn't it? You're approaching 0. Is it ever going to go below 0? No. There's an asymptote here. We don't see the end of it where it approaches the 0. It's still up here at 2 where it's cut off. But I could tell you before even reading anything about this scenario, based on that equation, because the denominator's degree is higher than the numerator's degree, I knew the horizontal asymptote was at 0. Does that make sense? Okay, so if you want to add that's in red, okay, the limit as t approaches infinity, that's our end behavior. So as this graph goes to the right, it's approaching 0. If you want to write to the side, that means there's a horizontal asymptote at 0. You can write that. All right, and then 5 says for the large values of t, which grows faster, the numerator or the denominator? And that's what I was saying when we first looked at the equation. It's the denominator because the degree is higher. So it's growing faster. It's being squared. It's a quadratic function in the denominator and a linear function in the numerator. The quadratic is increasing faster, right? It's the higher degree. So since the degree of the numerator is smaller than the degree of the denominator, there's that horizontal asymptote at 0 I was talking about. And then 6 says, how is your answer in question 5 related to the long run effect of anesthesia? It says, because the denominator is growing so much faster, the fraction expression is getting very, 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 very small. It's approaching 0. Does that make sense? Okay, so y'all can try the check for understanding under the quick notes on the other side, and we can go over some questions on those if you have them tomorrow. And then we'll be talking about 6.6 tomorrow. Remember, the delta math for 6.5 and 6.6 is combined into a single assignment, and it's active. If you'd like to go ahead and try and start any of it, you can, but it's not officially assigned to you till tomorrow, which means it's not going to be due until Tuesday before midnight. But if you have not finished the 6.4 delta math, that one's due before midnight tonight. So make sure you get that one completed. No, it was just a review to get you back in the mindset of rationals, and it'll help you refresh on those asymptotes.